Okay, so I'm now going to describe what the problem is. Okay, so ultrasound is very useful in scanning the inside of our body, right? If we could open the skin and see what's going on, we wouldn't need to get ultrasounds, MRIs, things like that. And but what's very difficult about ultrasound is that this is an ultrasound probe. Okay, now when you place the probe on the patient, it actually you take a slice, a two-dimensional image. There's a dot here. So depending on where the dot is, you're just taking that snapshot, okay? And it's that image that you see on the computer screen, okay? So what we found is that the most difficult thing people, students of ultrasound have problems with, when they start scanning, they don't see the three-dimensional structure, obviously. They see a slice. And if you just think about a slice of human body at different angles, it's very complicated. Okay, if you get a very nice slice in one angle, that's perfect image, but most of the time, you're going to get like an off angle. You're never going to get like a longitudinal or perpendicular. That's what you're going to get. So what happens is, they start scanning and they have no idea what they're scanning, because it's a two-dimensional slice, okay? Okay, so let's think about this. Why does that happen? There are three variables. The actual thing you're scanning, the probe position. You know the probe is a certain way, so you're cutting the slices in a certain way, and the image. If there was a way you could actually see, for example, the baby, where the baby is, how the baby is positioned, it would be kind of easy, because then you say, okay, the baby's head is here, I'm scanning like this, so I'm getting a cut through this, and that's the image I get. And then what you can do is, okay, well now I can turn it this way. Now I'm scanning and cutting the image this way, and that's the image that I get. Okay, for example, I think this is part of the video, but let's say a rough approximate, let's say a human body looks like this, right? So there are two main views, the longitudinal view and then the transverse view, right? So, okay, again, the dot is this way, I'm cutting this way, so if the baby's like this, and I'm scanning like this, the picture you get will be an oval, right? Okay, you guys see that? Now, exactly the same position. I don't move this at all. Just imagine this is inside the mother, right? I just turn this 90 degrees. So I'm cutting this way. So you turn it this way, so it's not an oval, but it's a circle. That's the fundamental problem that we want to show. Okay, so basically the simulator, what I'm thinking is that because you don't know what's going on. Now we can see it. Okay, we see this is the position. We have the probe this way, and we know what the image is going to be. In real life, you don't know what the baby is doing. That's why you get an ultrasound, right? If there was a way you could simulate a baby that you actually scan, that you can see. So you know the baby's lying this way, and what you're doing is basically just playing with the probe. Okay, you're going from here, 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 and you see how the image changes. Then you can learn really fast what the effect of turning the probe is going to have on the image. Okay? It's a little complicated, but you guys kind of get what the point is. So, okay, now, how do we do that? Well, there's certain criteria. First, we want to scan like a real image of a baby. So the fetus has to be kind of realistic. It has to be like a mannequin, or so that when you actually scan, because we're going to be doing a live scan of the simulator, it actually looks like a real fetus. So that's the first criteria, and it has to be scannable, because we're going to be doing a lot of scans. There are a lot of simulators that are just really expensive computers. When you go to like museums, you say touch this button and then this comes up, touch this button, that comes up, and those are like preset buttons. A lot of simulators, that's completely fake. It's very difficult to learn from that. So we're going to be doing live scanning of so a real fetus, and then, okay, this is the reason I brought this. Sorry, baby. I will use this baby. So a real baby, and the baby, let's say this is the abdomen, covered, some sort of a covering to simulate the mother's womb, right? The mother's abdomen. So we're going to be scanning like this, and the in-between has to be some sort of gel or fluid. You know, in real life, there's amniotic fluid, which is just pretty much water. But without that, there cannot be any air, because otherwise the ultrasound signal doesn't penetrate. And because we have to be able to do actual scans, those are the criteria. So the fetus has to be realistic. It has to be filled with some sort of water or gel that kind of simulates amniotic fluid. And then even the surface of this has to be kind of like skin. Actually, when I do a scan later, I'm actually going to do a scan of my heart to show you like what it actually looks like. I have an ultrasound machine. You have to put a little bit of gel. Basically, you need to get rid of all the air pockets. Okay. And then the other thing is, the probe has a certain depth. So you don't want the baby like right at the top. It doesn't. It has to be. Let's say the skin, the distance from the skin and the amniotic fluid is, let's say, about 1 inch. Because if it's like too thin, you really can't see. And it's going to be scanning around 3 inches deep. So around 3 inches where you want like the center of the fetus. Okay. And then the other measurement, we're going to simulate a 20 weeks of pregnancy scan, and the fetus is usually around 6 to 8 inches. So yeah, actually those measurements are on that thing I emailed you guys. So 6 to 8 inches, and then oh yeah, one other thing is, you know, sometimes the baby's this way, sometimes the baby's this way. Obviously we want the baby to be in different positions, because what we want to do is we want to, I don't know, like twist it or turn it or whatever, and then the baby just flips over, and then you start practicing. So somehow the baby has to be able to rotate like this way. I mean, this is pretty easy. You could just turn this. It doesn't really matter. You can just kind of turn it and just scan it. And also, you have to present this way too. So somehow it has to be able to kind of float. You know, when you like, you know, try to float something, like a piece of wood in the water, you know, it's always in like one direction. So somehow it has to be able to do that. It doesn't have to do that in every orientation, but it has to be able to stay either this way or that way. Yeah.
Does it have to be floating inside the fluid, or can it be like suspended with?
It can be suspended. Yeah, absolutely. As long as it can be, yeah, it can be absolutely suspended. Because the only thing the ultrasound cares is there's some sort of fluid, water, gel, consistency, whatever, no air pockets, and those depths.
Because you can just flip it over too, right? If you flip, you know,
yeah.
Let's say the back was closed. Yeah.
Right.
Okay.
So let's say, for example, yeah, you could even have it like kind of symmetric, kind of like this. Yeah, that's a good idea. You could just kind of flip it over like this. And again, the key point is it has to be very low cost. The simpler, the better, because the other thing we find is that there's a lot of tools that are very expensive, and they can't afford any of them. You know, the cheaper, the better. The easier to make, the better. The easier to transport, the better. The area we're working with, and a lot of these areas in the world are like this, they're in very rural areas. So to get there is going to be a long car ride. And you don't want to make something very complicated. So easy to transport, very simple. But that's a great idea. Absolutely, it could be totally symmetric. I didn't think about that. You can just kind of flip it over. Because what you could do is, I was thinking kind of like a slot machine. Somehow you kind of test yourself. You turn the baby, and then you don't know, and then you start scanning, and then you guess, the head is this way, and then you look, and then maybe maybe you're right, maybe you're not right. So you could do it like that, and then just kind of flip it over. So that's totally fine. I'm going to just stop here. That kind of explains that.